Until the turn of the 19th century, the sea serpent belonged to the class of legendary sea monsters, mythical creatures which haunted the imagination of men and the shadowy edges of marine charts. Its amazing appearance, size, rarity, and colors gave rise to sailors' superstitions and fishermen's tales. It had been seen attacking ships and was even reported to sport fearsome teeth, which made it resemble a marine reptile. In the 19th century, its teeth were to disappear, thanks to the descriptions of the first naturalists. Nevertheless, their observations were rare, unreliable, and scattered. Over the last 2 centuries, less than 250 beachings of dying, dead, or atrophied oarfish have been reported on temperate coasts all over the world. The longest ever found measured an astonishing 23 feet. Recently, through an incredible combination of circumstances, this giant fish had been observed, quite alive, off the French coasts. In the south of France, the carefree Riviera, with its yachts, citadels, and fine sand beaches. Every year, more than 12 million tourists delight in the pleasures of the warm waters of its slim coastal fringe. But who would have thought that the implementation of a strange scientific apparatus off the coast of these beaches would make sea monsters reappear? It was nevertheless to be the indirect consequence of an incredible experiment. In the heart of the summer of the year 2000, the Oceanographic Observatory of Villefranche-sur-Mer, in association with the top international space research organizations, undertakes the deployment 40 miles off the coast of Nice of an oceanographic buoy named La Boussole, the compass. Its goal seems more poetic than scientific. It is intended to collect and transmit data on the color of the water. This data will permit the calibration of satellites that observe the oceans. The color of the water, which varies according to the seasons and locations, is a good indicator of the presence of plankton. Thus, in the spring, microscopic algae and their predators abound. This is called a planktonic bloom. The algae's chlorophyll gives the seawater a green color. Here starts the vast food chain of the oceans. To study the evolution of the Mediterranean Sea, the observations of La Boussole buoy must be continuous over several years. The buoy must therefore be solidly anchored and periodically checked. To carry out this maintenance, a passionate biologist. My name is David Duquet. I'm a scientific diver and work at the Marine Lab of Villefranche-sur-Mer, where I am in charge of all diving activities. With tools as efficient as they are rudimentary, he intervenes only near the surface, on the submerged part of the buoy. Beyond this, he hands the work over to other specialists of underwater projects. To be at the heart of plankton production, scientists decided to anchor the buoy in the middle of a gyrating current. Problem? In the chosen location, depths exceed 8,000 feet. Therefore, a heavy mooring attached to almost 2 miles of Kevlar cable must be laid down. Lost in the immensity of the ocean, the buoy, its structure and its chain attracts many ocean wanderers. Barrelfish, amberjacks, pilotfish, and finally, the Atlantic wreckfish. These fish live in the photic zone, that is to say, the layers of water at low depth sufficiently exposed to light so that photosynthesis is possible. By the buoy's shadow cone, all find both food and shelter. Most swim by sight. Some come to feed on algae, which grows on the structure, and the smallest are devoured by the largest. Others, finally, such as pilotfish, are specialized in one particular activity: feeding on leftovers of meals or parasites of large predators that visit the buoy, including the most feared the great white shark. The shark has been observed only in the spring, near the surface, swimming in vast concentric circles around La Boussole buoy. A small population, estimated at merely 350 great whites, survives in the Mediterranean. What have they come to look for here, 40 miles from the Riviera coast? Most likely other visitors to the buoy, such as tuna. But no one has ever seen white sharks feeding here, and their visits are rare and brief. David can expect such unforeseen encounters during his monthly maintenance visits to the buoy. His mission? To clean the underwater optical sensors. The equipment is still just as rudimentary, but efficient. Solidly fastened to the diver so as not to sink 8,000 feet to the bottom. Risky dives. David is alone, in open ocean, without any protection. In less than a month, colonies of algae and seashells render the buoy's 20 measuring instruments totally inoperative. To every sensor, a specific brush. Cleaning creates vibrations emitted in all directions, sound waves, which are perceived by all the nomads of the ocean. They awaken their curiosity. These sounds propagate along the structure all the way down to the depths. Fish do not know man, therefore do not fear him. And their curiosity is reciprocal. David, under the buoy, is a man faced with the unknown.
Un jour, au mois d'avril, lors du bloom planctonique, l'eau était vraiment très trouble. Je venais de finir mon travail et je suis descendu inspecter le bas de la bouée au niveau du câble en Kevlar. Et là, j'ai vu un très long ruban argenté qui remontait des profondeurs.
The king of the herrings. Curious, but fearful. For the first time ever, a diver swims with the mythical fish. An ambassador of the deep comes to the borders of our world. David discovers that it swims vertically, not horizontally, like the sea serpents in ancient prints. Curiously, the tail of the animal is split. Could this be the result of an encounter with the great white shark? To answer this, David would need to get close and to observe the bite marks. Unfortunately, his bubbles seem to frighten the animal. This accidental encounter is too brief to examine the wound. After a few minutes, the crowned fish returns to the aphotic zone, depths where so little light penetrates that photosynthesis is no longer possible. To be able to anticipate other encounters, David must first understand how the giant oarfish manages to detect the buoy in the immensity and half-darkness of the Mediterranean Sea. Luckily for him, at thousands of miles from the buoy, a series of extraordinary events was going to enable scientists to reveal unknown facets of the biology of this mythical fish. In Japan, the giant oarfish goes by the strange name of Ryugu no Tsukai, meaning messenger of the palace of the gods. Over the several months of winter in 2014, more than a dozen giant oarfish of all sizes were deposited by marine currents on the shores of southern Japan. According to Japanese mythology, the beachings of the messenger of the palace of the gods announce an imminent earthquake. These sudden appearances have never been proved to be correlated to seismic activity in the region. But they offered Dr. Tyson Roberts, the world expert in giant oarfish, an unhoped-for opportunity to carry out a systematic study on fresh animals.
Wow.
Its anatomy would beat all records.
This is an oarfish that attains a total length of 8 meters, longer than any other bony fish, with perhaps one of the smallest brains, relatively speaking.
To prove it, he's going to use the latest technological advances in a veterinary clinic. The Japanese provided him with a magnetic resonance imaging machine, or MRI, which produces images in 2 or 3 dimensions of a living body. Applied to a giant oarfish head, the veterinarian MRI, designed for small animals, enables them to create images finer than with a human MRI, indispensable to isolate the brain of the giant oarfish with its ramifications.
I'd like to know more about its brain and its glandular system. Oarfish anatomy is basically got nearly all of the organ systems and organs of human anatomy. This really is the first attempt, a concerted attempt, to learn as much about oarfish anatomy as we can.
The MRI images confirm the initial hypothesis.
The brain is only about 1 inch long, and it's about half the size of the eye.
A pea in the head. Here is the size of the giant oarfish's brain. But, however fine it might be, MRI resolution cannot discern the nervous system associated with the brain. Fortunately, the X-rays of the veterinarian scanner will enable Dr. Roberts to resolve a tenacious enigma. How does the giant oarfish find its way in the pitch darkness of the depths? Fish can use sight, sometimes sound, but above all smell. However, in the giant oarfish, this sense seemed altogether absent.
I've examined now something like 35 specimens of oarfish, and I've never seen a nostril, the external opening of the olfactory organ. Nobody's ever reported nostrils in oarfish, nor have they reported an olfactory organ. With these large oarfish, I found the nostrils. And the nostrils are not on the side of the head. They're at the absolute front of the snout, and they open anteriorly.
The nostrils are thus situated inside its mouth, so to catch and locate odors in the twilight zone, the giant oarfish must keep its jaws partially open and continually pump water.
Now, it's quite possible that both of those, which are elongate slits, wider at the bottom than at the top, they could close. So opening and closing could provide a possibility of directional sensation.
The consequence is surprising. The giant oarfish is capable of working its way back up the trail of odors in the vastness of the ocean, simply by making pirouettes.
If you're receiving a strong olfactory signal in your nose, but you don't know where it's coming from, you face in the direction you think it might be. And if it's weak, then you close the nostrils, and then you turn to another direction where it might be and open the nostrils. And if it's stronger, then you home in on it by successively moving your head and opening and shutting the nostrils.
It's a real underwater game of blind man's bluff. When the eyes see only an infinite expanse of blue, the giant oarfish with its tiny brain can localize, go to, and remain around la boussole buoy, thanks to a particular smell. Could it be the smell of the buoy? That of a food source? Or another scent altogether emitted by a creature of the depths? To make a clean breast of it, David must dive to the very limit of the photic zone, where all light stops. As this is beyond his capacities, David calls upon a specialist of deep dives in the Mediterranean, Italian cameraman Roberto Rinaldi.
J'ai vraiment envie de rencontrer les régalèques. Mais dès qu'on est parti, en fait, je commençais à me sentir un peu perdu dans l'immensité de la mer. On va être des petits points minuscules dans le bleu. Et ça sera vraiment difficile de rencontrer ces poissons.
To approach it, he plans on using a respiratory apparatus which combines performance with discretion, the rebreather.
Aujourd'hui, grâce au recycleur, on peut plonger profond et longtemps. On va récupérer les mélanges gazeux qu'on respire. Mais la chose la plus importante quand on filme la nature, c'est qu'on ne fait pas de bulles avec le recycleur. Les poissons, ils sont habitués à tout sauf aux bulles. Avec le recycleur, on a beaucoup plus de temps et de chances pour approcher les régalèques.
On the way to La Boussole Buoy, David suggests diving under another nearby one, equally moored at a depth of 8,000 feet, a meteorological buoy simply named the Côte d'Azur. It's a sophisticated instrument that measures temperatures, swells, and wind speed, and supplies data to forecast centers. Under its metal skirts, this groaning structure seems to attract more fish in open sea than the boussole buoy. Its creaking carries over a great distance in all directions. Nothing is left to chance. Gone are the short monthly dives at La Boussole. Henceforth, David and Roberto stay for several days at a time at the meteorological buoy, diving at all hours, starting at dawn. They've synchronized their visit with the spring peak of plankton production, therefore of animal proteins. Thus, if the giant oarfish is indeed attracted by a source of food that gives off a smell, or by the sounds of the buoy, they increase their chances of an encounter. At the surface, velellas. These are not jellyfish, but polyp colonies that drift with the winds and currents. For his first dive, Roberto doesn't go down with a camera, but with a stick topped with a scouring sponge. This is intended to take mucus samples from the skin of the giant oarfish to conduct genetic analysis. David at shallow depths with his air tank, and Roberto deep down with his rebreather. Thus is organized the methodical quest for the giant oarfish. These serpent-shaped creatures are neither giant oarfish nor jellyfish, but salps, animals who filter bacteria and phytoplankton and develop their chain of fellow creatures by hermaphroditic reproduction. At a depth of 120 feet, where the warm and cold waters meet, where their food is abundant, they clone and proliferate. In this organic soup, Roberto made a record-breaking encounter. A 15-foot giant. The largest living oarfish ever observed in its environment. The longest bony fish ever recorded in the Mediterranean. Its tail isn't split, unlike that of the first animal observed by David. A unique opportunity to become acquainted with it before it heads back to the depths. To be able to take a mucus sample, Roberto relies upon the discretion of his rebreather and upon the fish's curiosity. About him and about the buoy. Curiously, the smooth, scaleless skin of the oarfish seems insensitive to this rough contact, to any contact. But once its curiosity has been satisfied, the giant heads back down into the depths. Covered with its precious mucus, the scraper is sent in alcohol for analysis to the University of Western Brittany. Eleonore Meheu tries to extract the giant's DNA and compare it with rare samples from beached animals.
En fait, il y a très peu de données génétiques.
In fact, there is very little genetic data available. We can learn a lot from a genetic study with samples from live animals in their natural environment.
Basées sur des spécimens prélevés dans leur milieu naturel. Après pas mal de mises au point techniques,
after quite a few technical challenges, we managed to extract DNA from the mucus samples and we analyzed it. We found a 10% variation between different individuals from the same species. It's quite surprising for a given DNA sequence. In fact, it looks like there are two different populations, two different species of oarfish, and our sample comes from one of them.
This data seems in keeping with the hypothesis of Dr. Tyson Roberts, who believes that there isn't one, but two species of giant oarfish. In the Mediterranean, the giant oarfish belongs to the species Regalicus glacinae, present in temperate waters all over the world. In the warm waters of the Pacific Ocean, it's the species Regalicus russellii which dominates. The differences in the morphologies of the two kings of the herrings are subtle. Glacinae possesses between 4 to 7 more crests on its crown than russellii. The University of Western Brittany focuses less on these morphological debates than on a most puzzling enigma. What does the giant oarfish feed on in the Mediterranean?
We even initiated some fatty tissue studies. We tried to reconstruct the food chain with the available samples. Instead of getting some stomach content, we used the fat which abounds in animal tissues. There's a direct link between the composition of the prey fatty tissue and that of its predator. Unfortunately, the mucus did not provide satisfactory results. Ideally, we need real tissues, like fins.
A mission which seems impossible, taking samples from fin tips, not from one, but from several living giant oarfish. Another difficulty, even during the plankton bloom, encounters remain uncertain. When the weather allows it, divers make several dives per day at one or the other of the buoys. David's statistics are eloquent. Out of more than 120 dives at La Boussole buoy, he saw a giant oarfish only twice. Luck does not exist. Only perseverance pays off. A giant oarfish answers the call of the buoy. And it is not alone. How can these open ocean fish meet up here at the same time? Probably thanks to their sense of smell. Still, they need to emit a substance which can travel over long distances with the currents. But what might this substance be?
A pheromone, that is a specific chemical produced by an oarfish to attract another oarfish.
Thus, the giant oarfish is capable of sending out a coded message, only detectable by other giant oarfish over very long distances. And when they're close, the giant oarfish communicate by using body language.
What is the significance of the dorsal fin crests and of the pelvic fin or oars, which give the fish its name. They look obviously like intraspecific signaling devices.
The divers are going to confirm this hypothesis. To be seen by its fellow creatures, the fish, with mirror-like skin, adopts an astonishing posture. The cross. These static postures should allow David to approach it and to take tissue samples. But he'll still need to be able to swim at its pace and force it to remain near the surface. Easier said than done.
Avec sa petite nageoire qui vibre, il bouge pas, il vibre sans arrêt, il est capable d'aller très vite. On peut l'appeler poisson piège parce qu'en fait il a l'habitude méchante de couler comme ça, mais il fait rien, il fait pas de mouvement. Est-ce que pour un poisson, la verticalité ça représente quelque chose comme pour nous?
For the divers, descending is easy, but they risk the bends by coming back up too quickly. One solution remains, passing gently underneath the giant oarfish. Over the course of several months, David and Roberto carry out more and more dives and fin samplings. Each time they return to port, they send the samples to the university laboratory. Just like the giant oarfish first encountered by David, most have mutilated bodies. The great white naturally appears among the list of suspects. This time, divers were able to observe in detail multiple scars. Dr. Tyson Roberts puts forth another hypothesis based on the numerous animals washed ashore in Japan.
The oarfishes typically undergo serial autotomy. What do I mean by that? I mean they undergo a consecutive series of self-amputation. It's like in a lizard when it drops its tail, except the lizard can only drop its tail at one place. The oarfish can drop the body posterior to the vent repeatedly, starting from just in front of the caudal fin, and then progressively breaking off additional parts that are either short or long, or short or long, or any length. It can, or once at a time, and it can do it all the way up to the vent, which is right here. So we can get oarfishes in which only this much is left.
Unlike the lizard, the giant oarfish doesn't abandon its tail to escape a predator, but for other astonishing reasons.
The autonomy, the extent of autonomy and the number of times autonomy is totally a matter of individual history. It's energy conservation to metamorphose into a body form where you're only conserving your gonads and your vital organs. But it's very rare in fishes. This is the only fishes known that do that.
To be able to prove this revolutionary hypothesis, one must observe the self-inflicted mutilation or find pieces of giant oarfish bodies at the bottom of the oceans. One might as well try to find fish bones in the muddy sea floor. But nearby to the village of Macerata, on the eastern coast of Italy, a geologist had a stroke of luck. Professor Patricio Bronzi just excavated in a nearby quarry a curious fossil dating back some 2.2 million years, which had surfaced after a tectonic movement.
Questo è l'unico esemplare ritrovato al mondo di Regalegus fossile. Si tratta della parte posteriore del corpo e è rivoltato su se stesso, ma noi possiamo aprirlo.
The principle of autonomy was thus engraved in ancient maritime sediments for all eternity. Other clues, notably its feeding habits, might be found by lipid studies, thanks to the fins collected by David and Roberto. Still, it's now necessary to identify the preys of the giant oarfish, and thus their lipid signature.
Là, on va poser deux pièges.
We're going to sink some special traps. One is going to be near the surface to catch shallow drifters, and the other one deeper to catch small fish and crustaceans. Like an underwater beacon, the light from the trap arouses the curiosity of the vagabonds of the open sea. They swim around the net or try to find refuge in it. During the day, the catches are meager. But when the trap is immersed for a whole night, the morning collections reserve many a surprise. These small shrimp are none other than krill. This species, present in abundance in the northern Atlantic, makes its bioluminescent organs glow in the aphotic zone of the Mediterranean. Better, after sample analysis in the lab, the lipid signature of this krill is found in the flesh of the giant oarfish. At night, krill make their vertical migrations towards the surface to feed on plankton. Thus, they avoid diurnal hunters like most of the fish which swim around the buoys. But in their wake, they lure all the predators whose sight is adapted to very weak light. Among them, the giant oarfish. To observe their feeding habits, Roberto and David will have to dare night dives. In open ocean, using rebreathers, without any bearings.
Il faut vraiment être attentif, on est dans le noir complet et on n'a pas de possibilité de s'orienter.
Strange, ghost-like visitors make their appearance out of the infinite darkness. Like superorganisms, these aliens of the deep ascend together each and every night for an exceptional feast. It is the largest biomass migration in the world. In the stinging traps, krill, a promising sign. But where have the fish gone? They seem to fear great invisible predators. And huddle together. Likewise, faced with ghostly threats, David and Roberto regroup to keep a better watch in all directions. A sunfish, false alarm.
Plonger la nuit au large, c'est comme un voleur qui rentre dans un magasin de jouets. Avec les faisceaux de lumière, on va révéler des couleurs magnifiques, des couleurs étonnantes qu'on ne voit pas le jour. On sait qu'il y en a beaucoup de jouets partout. On ne voit très peu, mais c'est suffisant pour être émerveillé par ce qu'on voit.
The king of herrings, in all its splendor. The diver's underwater lights reveal multicolored reflections. What use is this shiny skin in total darkness? Maybe to mirror the dim lights of the krill and blend in with its prey? It's a mystery. All the more so, as the oarfish pays no attention to the krill. Nevertheless, it partially opens its mouth, as if to catch invisible prey. The diver's light seems to disturb it. A closer look reveals tiny visitors which swim in and out of the mouth of the oarfish of their own free will. Parasites. These are external parasites, which do not remain permanently in the body of the giant oarfish. Internal parasites, on the contrary, pass from prey to predator. These give scientists a clue as to the oarfish's predators. This at least is the opinion of American doctoral students specialized in the study of fish parasites. At the University of California at Santa Barbara, the stomach contents of stranded oarfish enabled Sarah Weinstein and Ana Garcia to make astonishing discoveries.
Parasites offer a really great snapshot of their life history, that information that maybe you wouldn't get any other way, because most of these parasites have complex life cycles, so they go through multiple hosts. For instance, we've found at least 3 different species in nematode. This is interesting because one of them looks a lot like a species that uses marine mammals as its final host.
After further DNA analysis of the parasites, scientists at the University of California in Santa Barbara deduced that the oarfish fall prey to deep-sea predators such as sperm whales because they found some juvenile nematodes in oarfish and some adult nematodes in sperm whales.
These nematodes actually end up in the oarfish. They're picking it off of something they're eating, like krill.
The krill also provide oarfish with bioluminescent bacteria. But until now, no bioluminescent organ had been found on the oarfish, for a good reason. No one had ever dived in the twilight zone with a living oarfish. So David and Roberto suggest replacing the ordinary lamps with ultraviolet ones, which reveal bioluminescence. Notably, the bioluminescent lures of the krill eaters. Unfortunately, the range of such UV lamps in water is far less than that of ordinary lamps, which cancel out their effect. The task is both dangerous and difficult. David is going to have to spot the oarfish with ordinary white lights, then turn them off and let Roberto and his UV lights try to approach it. A daring challenge. A success. The UV lamps reveal two bioluminescent organs on the oarfish's head. One on the forehead, the other under its chin. Like luminescent miniature traps, these organs enable the oarfish to be both seen and to lure its prey. Its beauty can also prove fatal for divers.
À un moment donné, je me suis rendu compte que sa crête montait vers le haut. C'est comme ça que j'ai réalisé qu'on était en train de descendre à toute vitesse. J'ai regardé la montre, on était à 71 mètres. En fait, c'était une piège. Ce petit poisson, il m'a amené chez lui, dans son abysse.
The sea serpent is no longer the mythical creature which devours ships. Its only menace, its spellbinding beauty. David and Roberto looked deeper to uncover the first secrets of the oarfish. The rare, eerie, yet harmless ghost of the open seas.